Over the course of the next number of lessons, we'll use the Fusion Client Core SDK to create a client application capable of using all the features exposed by the API: voice, video calling, instant messaging and presence, and synchronizing application data using AED, or Application Event Distribution. In this video, we'll run through the anatomy of the application we'll write, considering the different components, the role they'll play, and how they'll interact together. Now, we've looked at the components of the overall solution in previous lessons, but let's add a little more detail to the discussion and consider the overall picture. You'll recall that the application will reside on a web server that the user must have HTTP access to, and which in turn must have HTTP access to the Fusion Web Gateway. Once provisioned, the client will establish a WebSocket with a Fusion Web Gateway, over which it will issue instructions to make calls and publish and receive presence information and AED data. Now, since we'll want to ensure that the enterprise network is properly protected from the external internet, that exchange between the client app and our web app, as well as the subsequent WebSocket communication between the client and the Fusion Web Gateway, will probably go through a reverse HTTP proxy sat in the enterprise DMZ, protected by firewalls on both the internal and external borders. The media broker, responsible for handling RTP and secure RTP traffic, also fits into the DMZ, configured over HTTP from the Fusion Web Gateway. Now, use of a reverse proxy is not mandatory, but will offer a number of security benefits, especially in use cases involving clients situated on the open internet. First, it provides topology hiding for the internal network by presenting a single ingress point for HTTP and WebSocket traffic to terminate against. This also has the nice benefit of remedying a number of cross-site origin issues related to hosting the web app on one server, but the client needing to establish a WebSocket with a different server, the one hosting the Fusion Web Gateway. With the reverse proxy, there's only a single domain presented to the client and therefore no cross-site issues. Third, if using secure transport protocols, encryption overhead can be offloaded to the reverse proxy, freeing up resources on the web server and the Fusion Web Gateway. We've verified support for 3 of the biggest reverse proxies available, including Nginx, Apache, and F5 Networks Big IP, but the client SDK will be happy working with any reverse proxy with WebSocket support. Thankfully for us application developers, the presence of a reverse proxy in the overall architecture is largely a transparent detail of the network that we can largely ignore. We only need to be cognizant of it at one place, when we provision a session on the Fusion Web Gateway the client will connect to. We'll explain what to do in the appropriate module. Now, it's helpful to mentally divide the application that we'll write into the 2 distinct roles we mentioned a few moments ago. One, the server-side piece that will talk to the web gateway and create a session, and then second, the client-side piece, the part that will execute in the user's browser and will enroll against the session created on the gateway. Since it's executing in the browser, the client-side bit of the app will be, of course, written in JavaScript. But there are no such language restrictions on the server side. You can write in any language capable of sending JSON over HTTP and that's capable of serving up a web page. In my code, I'll be using PHP, but it could equally well be Java, Python, or whatever you prefer to write your server-side code in. Let's take a look then at the actual sequence of interactions. For simplicity, we'll not worry about the firewalls or any specific implementation details of the enterprise network. We start with the user accessing the web app, going through the DMZ reverse proxy to do so. The purpose for this initial exchange is to enable the web app to determine appropriate details to use when creating the web gateway session. Perhaps the app has the user log in and authenticate as a particular extension that matches one of the users on the enterprise registrar. Now, you don't have to access an external SIP registrar, and in fact, the web gateway comes bundled with an internal registrar that enables you to get up and running quickly. If you're building a client that needs to be able to receive inbound calls, you do need to have it registered somewhere in the network to enable it to be reachable. If, however, you only plan your clients making outgoing calls, or in other words, calls that are made are always inbound to the enterprise, then the registrar is not required. Even though you may be working with the registrar embedded in the web gateway, the SIP behavior is the same as though you're working with an external one. So we'll go ahead and outline the interaction. Once the web app knows the details it wants to use, it'll need to perform an HTTP post over to the gateway, sessions, session API URL on the web gateway. The payload of that request will contain the JSON description of the enterprise user the session will pertain to, and the details for the client SDK features we wish enabled for the session. It's also in this provisioning JSON that we'll need to know the address of the reverse proxy if deployed, so the remote client will know the correct address to establish the WebSocket with. We'll also need to supply our web app ID so that the gateway knows to trust our web application. So that post request goes off to the gateway. In return, the gateway responds with a 200 OK HTTP response, the payload of which again contains some JSON, this time just containing the string session ID, which has encoded in it the address to be used for the WebSocket. This session ID then needs to be delivered from your web app over to the client running in the browser, since it's needed by the client. It doesn't really matter how you get it to the client, perhaps put in a cookie or inject it into the page HTML, just so long as the client can learn the session ID and can then pass it as a parameter to call start with the web gateway. This in turn will cause the WebSocket to be established between the client and the reverse proxy, and then from the reverse proxy over to the Fusion Web Gateway. Through that WebSocket, the web gateway will receive the instruction to start a session, which will cause it, if the session were provisioned for inbound calling, to perform a SIP registration with the registrar using the account details provided during the earlier JSON exchange. If some other service were provisioned for the session, it will also do the appropriate thing to initialize that service. Now, once the SIP registration succeeds and the gateway receives a SIP 200 OK back from the registrar, or any other necessary initialization completes, the gateway will talk to the client in the browser and cause the designated onInitialized callback function to execute. This then is the signal for our application that we've completed our enrollment with the HTTP gateway and we're now ready to do something interesting, like create a call to some address and then dial it. The web gateway would then act as the SIP endpoint in that call, handling the downstream signaling with the registrar and beyond, and in turn triggering the relevant callbacks to the app in the browser. Makes sense? I hope so. Now, one quick thing I want to underline before finishing. The application ID is configured on the web gateway, but must also be known by the web application and used as a parameter in order to create a session ID. That session ID is then used by the client to enroll with the web gateway. Notice that the web app ID is never sent to the client in the browser, and also that the session ID is never directly used by the web application server. It's of course important to keep the purpose of these ideas clear in your mind. And with that, we've come to the end of this video.